Thank you. Thanks for having me. Maybe we can kick off the intro video. All right, so I definitely spent probably more time than I should building a 1-minute video, but hopefully you guys thought it was cool, and hopefully it introduced my topic well. This is my POC DarkWatch. It's an investigation agent. Over the last year, I've spent some time researching and developing investigation and research agents. Here, DarkWatch's simulation objective is hunting social media accounts opposed to Donald Trump policy. So I wanted to bring a light to the potential for misuse of investigative agents like this. But again, there's a lot of use cases for an agentic system like this. And my hope is that you'll focus on one of those alternative use cases rather than surveilling your enemies on social media. All right, so we'll start with the architecture here. We'll start at the very top, the blue chunks. We have raw social media data. This is a very large CSV of tweets. Of course, we're not going to use scrape. We're not going to scrape live Twitter data and all of that. That would be extremely unethical. So we initially filter this large CSV with some keywords to create nodes and relationships. To the left, for our graph database, we're using Neo4j. Above it, you can see the data model, the large blue node, users, pink node is tweets. We extract out hashtags as nodes, and we also run TF-IDF, term frequency, inverse document frequency over the tweets. Basically, we're just looking for important terms in the tweets in relation to the tweet corpus as a whole. And we extract out the top two highest scored terms per tweet and graph them as TF-IDF nodes denoted in yellow. So you might notice all the relationships are running inward directionally towards the user. That's by design. The last thing we apply to the data model is a graph data science algorithm called PageRank, where essentially we're just looking at the influence of a node within a network of nodes. And it does that by assessing the incoming relationships, what other influential nodes that node's connected to, kind of like a popularity contest. And that rounds out our data model. Central to the diagram in brown or beige is the agent. You'll notice that there's actually 3 siloed states here. So we have an evidence memory state, messages memory state, and a hypothesis memory state. The messages memory state probably be known to many. It's that typical conversation memory, role, user, role, assistant. The evidence memory state is evidence that the agent has extracted through the investigation cycle and appends to that memory. And hypothesis memory state is as it sounds, the agent hypotheses or its ideas, but specifically also how they change and morph in the investigation cycle, given the evidence that it's weighing them against. So that's kind of where the agent starts. It has visibility into the data model of the graph, and it has an objective, in this case, that we've defined on the last slide, and it builds a hypothesis on how to explore the graph. So it moves into the red blocks, wants to investigate its hypothesis. It does this by generating Cypher queries, which are Neo4j's graph database language. We don't have any predefined queries, and we don't example the best way to explore the graph The agent's really free to explore the graph as it sees fit based on its hypotheses. With this dynamic nature comes some challenges. Of course, there's going to be queries that don't work and so on and so on. So we give it a debug method and also a debug state so we can get those queries working, and we hit the graph database. After the graph query results return to the agent, it looks, can I extract some evidence based on the hypothesis that I'm investigating? If I can, append it to the evidence state. Does this particularly change the hypothesis? Yes, no. Anyways, it continues in the cycle until the agent's like, okay, I've seen enough. It sends the finalized signal, and it creates finalized insights based on the evidence and hypothesis. At that point, it will actually update nodes in the graph database as a form of long-term memory, specifically the user nodes that are identified in the finalized insights. They get updated with the insights. And this serves two purposes. One, of course, we don't want the agent just reinvestigating the same networks of nodes. But also, if there's an adjacent investigation, the agent might be able to just see those insights on a group of nodes. And rather than having to reinvestigate those to get an insight to jump off of, it's already there and it can do so. Lastly, the agent's going to want to get some new raw data into the graph to continue investigating. It does something very similar to what we did. It's instructed to choose some keywords based on the final insights. It then uses those keywords to filter the social media data, and then it creates nodes and relationships, reruns PageRank, and starts an investigation cycle. Something to note, though, here is then we zero out the memory states of the agent and actually pull out the reasoning the agent uses for deriving those keywords, and we append it to the fresh hypothesis state. So this gives the agent some visibility into what happened in the previous investigation, why these terms were chosen, how the graph might be extended, and where to keep investigating. Another thing that I've been pretty interested in this year is this concept of adversarial tension. So think about it as like tension in an agentic system with the intent of outputting a better outcome for the system as a whole. So you can think of it even as like in a multi-agent system where you have two agents with conflicting personas, and really they're critiquing each other's reasoning or outputs, but then the final output is much more rich or robust. The idea here, we don't have a multi-agent system, but DarkWatch has this adversarial tension by having a hypothesis state and an evidence state. And we specifically instruct the agent to weigh your hypotheses against collected evidence. And so if the evidence contradicts the hypothesis, you'll see the agent pivot or refine. If it partially confirms it, you'll see the agent dig down and kind of go down that rabbit hole. And like I was saying before, we don't have any statically defined queries or exampling. This is the best way to explore the graph. So we need some type of debug routine so that we can fix up those queries. Essentially, we pass in the reasoning behind the query in the first place. We pass in the faulty query and the query results. And in this case, we say you got 3 max attempts to fix this up, or you got to go on to a new idea because this is not going to fly. Typically, what I've seen though, within one turn of the debugging cycle, it usually fixes the query up, and it's usually directional mismatch on the relationships that usually cause it some hardship. Okay, so part of any investigation is knowing when to pivot and knowing when to give up, throw in the towel. And so we give the agent this example. If you detect important new evidence, you might propose a fresh hypothesis. And we can see it in the agent UI there where it's saying evidence suggests that they, in this case, user 14247, which had this user in previous in previous turns, has a username of like resist or resistance or something. And the agent really kind of clung on to that with like other terms like Trump and things like that. So it figured, hey, this is a good place to investigate some anti-Trump sentiment. As it turns out, this user is critical to Democrats and supportive of Trump. So this is in complete polar opposite to what the agent's goal is. So then the agent says, okay, I recognize that. We should pivot to searching for anti-Trump hashtags. It recommends some hashtags to locate other potential users who might exhibit anti-Trump sentiment. So it's saying, okay, this investigation pathway is no good. Let's pivot. Let's go on to something else. Ultimately, in this investigation cycle, the agent finalized with no findings. But no findings are actually good findings in this context because we don't want the agent to just make up stuff just to fill that space. So you can see in the prompting for the summary prompt someone else mentioned actually using the asterisks. Agree, it works good. Critical, one of the elements under critical is do not add users and tweets to this report that don't align with your objective, and we re-inject the objective. So that seems to do it. The agent also has visibility into the progression of the investigation. We pass in the hypothesis state, the evidence state, and also a list of users that were of interest to the agent during the investigation cycle. And so you can see in the agent UI, no newly identified users. So basically it's to say, I got nothing on this one. And the last method in the code, update persons of interest. Again, if there were key findings here, those nodes would be updated with the findings. In this case, nothing because there was nothing. Now, just because a previous investigation cycle didn't bear any fruit, that doesn't mean there's not ideas or something that can be used for the agent to go forth and get more raw data and use some of the ideas it had to do so. So like in this case, we're telling the agent, derive 3 to 5 keywords, reason these search terms are going to be used for filtering new raw data and extend the graph to continue your investigation. And something to note, like, of course, this is a simulation, but if this was real, like a real surveillance tool, it would be typically paired with some type of like recursive web research agent or scraper or smart scraper. And this deriving key terms to like get in fresh data would be very important. And so you can see in some of the key terms that it chose, the one I'm going to zero in here, which is Biden, not for the obvious alignment that this key term holds, but more so in the previous turns of the investigation. It was really interesting to see that the agent kind of zeroed in on this term either in its reasoning, it was reasoning about Biden, or tweet context that had Biden in it. Or specifically, it chose Biden as a term to search the graph with. So it's interesting to see it bring it forth into its chosen keywords to extend the graph and to then go forth and investigate. And then you can see it. We got 2,000 records back, and we built a graph structure from that. And as I was saying, at this point, we zero out the agent state. But again, to give it some visibility, we append this reasoning. So specifically, we append, use these keywords and ideas to start your investigation. And then we inject the keywords themselves and the reasoning behind it. And you can see the agent responding in its reasoning that it hypothesizes that these tweets with these specific keywords could indicate negative or hostile sentiment towards Trump. It also says that it's going to use these keywords to search TF-IDF nodes specifically because it will reduce noise, which is interesting. And then it's going to return the results in descending PageRank order. So again, it's embracing that idea of influence and looking at the most influential results first. So it's pretty cool to see it embracing these concepts and techniques as it's going through its investigation. And then a few cycles later, it's really started to zero in on an anti-Trump subnetwork. On the left, you can see a graph, a little arrow pointing to a larger light blue node, which are user nodes. You can see some other user nodes connected, pink tweets, hashtags are the small dark blue. And in this case, the user, the Tribune, it's identified central to an anti-Trump network. It's talking about its PageRank in relation to other nodes in the cluster. But it's also saying that what's interesting is investigating the user's tweet content, mentions, and hashtags could reveal additional anti-Trump relationships or security threats. So the agent's also instructed to take a multi-perspective view to validate its hypothesis. So don't just like jump to a conclusion because you got one piece of evidence, which is kind of cool. And then finally, the agent is going to finalize the report again. Here, we definitely have an objective complete. You don't see it here, but it gives an executive summary, key insights on the left. So it's giving facts, users involved, why it's choosing these elements for the report. On the right, relationship maps, how they're involved, hashtags usage, and just kind of summarizes its findings. And in this case, these nodes would be updated and saved for long-term memory. And that's all I got for you guys.
Excellent. Thank you so much, Jeff. We do have time for a quick question or two, depending. Um, One from the audience. How do you use separate accounts for adversarial attention so that the LM is not learning and trying to please? Are there models that do better with each hypothesis and critique?
Um, so I actually kind of missed I didn't hear part of the question. So maybe if you could repeat it for me. Sorry about that.
I will both repeat it and I will throw it into our internal chat. I might get master for you to find. And now I lost the question. Do you use separate accounts for adversarial attention so the LLM is not learning and trying to please?
So yeah, in short, no. I mean, it definitely there could be some bleed there. The point is, in the React prompt itself, we're separating out these states and injecting them separately so that it's really kind of front focus for the attention. Sure, there could be some bleed. There could be definitely some different ways of doing this, but I don't use separate accounts or really kind of maintain a strong wall there.
And I wrote time for one last one. Given your experience in red teaming frontier models, what concerns you most about how autonomous agents like React could evolve in the wrong hands?
Yeah, so I mean, as a broad context, definitely biological risks. Assisting, let's just say, a biological co-pilot that could even run offline on some decent consumer grade hardware. You have a capable model that say is you use something called card. It's a card database. It's an antibiotic you can get antibiotic resistance information, and you just pull a bunch of these resources from the science community. And you, of course, if you're a bad actor, you're using the model to help unlock and lower the barrier to entry to be able to like use something like CRISPR-9 technology or start to play and genetically modify these viruses, or even creating like anthrax or something crazy like that. That's where I really worry. Someone with a STEM level background of education, how could these models and with the proper framework empower these individuals? Of course, they would be sinister individuals to like cause significant harm. That's where really I see that's what keeps me up.
Wonderful thought to leave us with here. You're welcome. Tracks. Nothing better for signing off. So, all right.